Greetings everyone and welcome to the ninth video in this 10 video series. My name is Vyom Khanna and I'm thrilled to be with you all today. In the previous video, I hope you learned a great deal about Node MCU and how you can use them to send data virtually anywhere. In the last video, we explored not only the software but also the hardware of Node MCUs and how you can integrate them into your projects. Now, we are nearing the end of the series, but we still have time to look at how you can code a Node MCU along with some great applications of IoT which we will be delving deep into today. First, let's take a look at an air pollution monitoring system using IoT. In this project, we will make an IoT-based air pollution monitoring system monitor the air quality over a web server using the internet. The system will also trigger an alarm when the air quality goes beyond a certain level, which means that there are sufficient amounts of harmful gases in the air, such as carbon dioxide, smoke, alcohol, benzene, and ammonia. It will show the air quality in parts per million on the LCD and as well as on the web page so that we can monitor it very quickly. In this IoT project, you can watch the pollution level anywhere on your computer or mobile device. We can install the system anywhere and trigger some device when pollution goes beyond a certain level. For example, we can switch on the exhaust fan or send an alert, SMS, or mail to the user. Here is the list of required components for this project: an MQ135 gas sensor, an Arduino Uno, a ESP8266 Wi-Fi module or a Node MCU, a 16 by 12 LCD, a breadboard, a 10,000 ohm potentiometer, a 1000 ohm resistor, some 220 ohm resistors, and a buzzer. So, let's quickly move on to the circuit diagram. First of all, we will connect the ESP8266 with the Arduino. The ESP8266, or simply the Node MCU, runs on 3.3 volts, and if you give it 5 volts from the Arduino, it won't work correctly and may get damaged. So, we will connect the VCC pin and the CHPD to the 3.3 volt pin of the Arduino, not the 5 volt. However, while the RX pin of the Node MCU works on 3.3 volts, it will not communicate with the Arduino when we connect it directly. So, we have to make a voltage divider to convert the 5 volts into 3.3 volts. This can be done by clicking 3 resistors in series. We connect the TX pin of the Node MCU to pin 10 of the Arduino and the RX pin of the Node MCU to pin 9 of the Arduino through the resistors. Now, the ESP8266 Wi-Fi module or the Node MCU gives your project access to Wi-Fi or the internet. It's a very cheap device and makes your project extremely powerful. It can communicate with any microcontroller and is one of the leading devices on the IoT platform. Then, we will connect the MQ135 gas sensor with the Arduino. Connect the VCC and the sensor's ground pin to the 5 volts and ground of the Arduino, and then the analog pin of the sensor to A0 of Arduino, which is the 0th analog pin. Next, we will connect a buzzer to pin 8 of the Arduino, which will start to beep when the condition becomes true, or in other words, when the sensor detects a gas. Lastly, we will connect an LCD to the Arduino. The connections of the LCD are visible in the diagram. I'm not going over them as we have limited time, and they have already been explained in the previous videos. Just look at this self-explanatory and cohesive diagram, and all your problems will be solved. Note that the MQ135 sensor can sense ammonia gas, nitrogen oxides, alcohol, benzenes, smoke, carbon dioxide, and many other gases. So, it's a perfect gas sensor for our air quality monitoring project. When we connect it to the Arduino, it will sense the gases and we will get the pollution level in parts per million. Now, the MQ135 gas sensor gives outputs in the form of voltage levels, and we need some way to convert it into parts per million. In order to do so, we use a specific library for the MQ135 sensor. It is explained in detail in the code explanation section of the video below. Now, the sensor gives us a value of 90 when there is no gas next to it, and the safe level of the air quality is 350 parts per million, and it should not exceed 1000 ppm. When it exceeds the limit of 1000 ppm, then it can cause headaches, sleepiness, stagnant, stale, and stuffy air. If it exceeds 2000 parts per million, it can even cause increased heart rate and many other diseases. When the value is less than 1000 parts per million, the LCD and web page will display fresh air, and whenever it increases to 1000, the buzzer will start beeping, and the LCD and web page will display poor air, open windows. If the value grows to 2000, then the buzzer will beep continuously, and both the LCD and the web page will display danger, move to fresh air. Now, here is the code for this fantastic IoT project. Bear with me, as I cannot go deep into an explanation here. We have limited time and many more projects to showcase. If you want to complete this project yourself, copy the code on the screen right now. It is quite self-explanatory, and if you encounter a word or command you don't understand, do a search for it. Now that we've already created a pollution detecting system, let's try to make a flood detection system using IoT. A flood is a major natural disaster that causes massive loss to the environment and living beings. When floods occur, getting emergency alerts of water level status at riverbeds in different situations is crucial. In this project, the objective is to sense the water levels at riverbeds and check whether they are in the optimal condition or not. It alerts people through LED and internet applications if the water level rises above the safe limit. Here, we use an ultrasonic sensor to sense the river levels and a Node MCU ESP8266 to process this data. The data will be uploaded to the IoT cloud, using which the river levels can be graphically monitored from anywhere in the world. Now, let's take a look at the components required. An ESP8266 Node MCU, an ultrasonic sensor, a power supply, LEDs which can be red and green, a breadboard, and some jumper wires. Remember that we have used the ESP8266 Node MCU to create numerous projects in the past. Now, take a look at the above diagram to see the working of the IoT-based flood monitoring system. This is not the circuit diagram, that will come up later. Here, the ultrasonic sensor is used to sense the river's water level. The data output from the ultrasonic sensor is fed to the Node MCU, which is processed and sent to the IoT cloud for graphical monitoring and to send critical alerts. Here, a red LED is used to alert critical flood conditions, and the green LED is used to indicate the normal situation. An ultrasonic sensor works on the principle of ultrasound waves, which determine the distance to an object. An ultrasonic sensor generates high-frequency sound waves, and when this sound hits a certain thing, it reflects an echo sensed by the receiver. By using the time required for the echo to reach the receiver, we can calculate the distance to an object we target. Now don't worry, you've already studied this formula before, so this is just a recap for you. The ultrasonic distance sensor consists of two ultrasonic transducers. Among them, one acts as a transmitter that converts the electric pulse of the microcontroller into an ultrasonic pulse, and the receiver receives the transmitted pulses. If it gets them, it produces an output pulse, whose time can be used to determine the distance from the object. Now, that's all the theory you need to remember for the flood-based detection system. We'll continue with the circuit diagram, the coding, and the entire explanation in the next video. So stay tuned and make sure to revise all the concepts that you have learned. Thank you, and see you next time.